Uh-oh. Hmm. Looks pretty good. Woof. Okay, I do this. Yes. Did I do this? No. I see. Exactly K non-empty subarrays, alpha R, subarrays may overlap. Values defined as the max minus the min. Okay. So max is 5, min is 1, times 3, so. Split and merge operation. Choose a subarray and remove the subarray. Reinsert the removed subarray at any position in the remaining array. Interesting. tiny. 6? What if you just backtracked? Well, there's only 6 factorial possibilities, so 720. You could say just give the literal tuple of the answer and then have, I guess, O of n squared, so times 6 times 6 is 720 times 36. Then that gets you the transition, and then you're just like, for every single tuple, yeah. Well, no, because it would be O of n cubed. You could take any subarray and move it to any spot. Okay. X is B, return res for I in range n, for R in range L plus 1 to n, n plus 1. X from L to R for I in range n, Z equals X up to I plus Y plus X from I on So you say, take it out, you have the portion, you have the removed part. Test 1, 2, 3, okay. You have the removed part, you say add it in anywhere. If scene not in scene, looks pretty good. I don't know. Okay, this is the big one. Exactly k distinct non-empty subarrays of nums. So I guess you'd say do as many of the largest and smallest as possible. I'm guessing k can be giant. Yeah. So look at the largest. And smallest. Do as many of those as you can. And then add in the second largest and the smallest, or the largest and the second smallest. Each should take O of 1 to parse, but there's O of n squared of them. But I think if you're smart about it, there doesn't need to be. You could just say take the whole array, that will always be the minimum, or the maximum, and then have r minus 1 and L and r and L minus 1, if you haven't already seen them. Do that 10 to the 5th times, take a heap. Why would that not work? You just have a sparse table, it's like max and min. The O of n log n, or k log k plus n log n. Why would that not work? So start with everything. Say you used this. What's the next biggest thing? K is not that big. I don't see why that wouldn't work. Array function query LR so length is R minus L. J equals, or I guess I equals 0 while 1 to the I. See, if length was 1, you'd want to stay at 0. So while it's less than length, I goes up. Okay, res equals table at I at L. Res equals R minus length. Is that what it would be? So if you had length equals 3, you would go up until you're in the 2's array. You would say L is here. 1, 2, 3. R is here. So you'd say that's the first one you have to check. And then this is the second one you have to check. So it would just be R plus 1 minus length. Is that what it would be? Sorry. Let's try another one. Length is equal to 5. So you'd say, I want to check here, and I also want to check here. Right? That way you'd say 1, 2, 3, 4, getting those. 1, 2, 3, 4, you get those. So R plus 1 minus length. What if it was 7? Then you'd be here. You'd still be in 4, so you'd say length is there. So 1, 2, 3, 4. And then length you need there too. So 1, 2, 3, 4. It's definitely not R plus 1 minus length. It's just R minus the current power of 2. So if length is 7, the power would be 4. So therefore I would be 2. So you could just say 1 to the I. Return res, that's O of 1. Okay. Create a copy. I is 1, while 1 to the I is less than n. Well, 1 to the I is less than n, so you're currently at I equals 1. So occurs that for j and range n minus I. I think I'd rather not do it that way. I think I'd rather just say x equals 2. While x is less than n, something something x goes up. For j in range n minus x. I think it's probably n plus 1 minus x. So if you had 5, you'd say, okay, that's the first one. The second one is going to be 1, 2, 1, 2, 1, 2, 1, 2. And then 1, 2, 3, 4, 1, 2, 3, 4. So that's plus 1 minus 2, plus 1 minus 4. Cur.append table and -1. Maybe I'll say it all the time. Prev at j, prev at j plus 1. No. Prev at j plus x over 2. So for the first one, it would be j and j plus 1. But then for this, it would be j and j plus 2 would lead to this. Okay. X multiplies by 2. Table.append cur. Print min sparse. I'm not going to write that every time. Dot query, let's say 1 to 3. So this should be for indices 1 and 2. It should say 2. 3 were given. Shit. If I say 0 and 3, it should say 1. I is 2. That makes sense. So I think this needs to be that. I minus equals 1. One and 2, though. That's weird. No, that's not weird at all. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So one of them should say 1, one of them should say 8. Perfect. If I said 1 and 7 now. So we should have 1 and 7. Seven, 14. Okay, I'm convinced that this is a fine sparse table. So with that in mind, let's say H equals mass.query 0 to n minus mis.query 0 to n, 0, n. Okay. That's that. What am I doing? Taking the sum? Yeah. 4. And then it is seen. Okay, heap pop H, res plus equals X. If L minus L plus 1 are not in scene, if L is less than R, then you bother to do this, but that should never happen. But in theory, you'd like fuck up if this was negative and everything was 0, so you could have that happen and it would be really messy. So if L is less than R, if L plus 1 comma R not in scene, do something. If L R minus 1 not in scene, do something else. So here you'd say Y equals push h, y, L plus 1, R. This is going to be L plus 1 to R. YL R minus 1. This should be the minimum. I want the maximum. So minus equals just reverse it. Okay, res minus equals x. Min minus max, you'll get the, they're all negative, you'll get the highest, you'll subtract it, okay? Okay, n is 4. So if it's an even power of 2, it probably fucks up. 4251, so it says 4251, 2, 2, 1. It needs one more. So while x is less than or equal to n, and then it'll say n plus 1 minus x, you have one more. Yeah. 3, that's fine. Okay, now it says 1. Four, 12. Looks pretty good. I'll just submit, I guess. Damn. Didn't account for the 1. No, that's fine. So then where's the problem? Res equals table at I at L. This should be 0. It's negative 1. I think that's the world where L and R, where there's exactly, K is exactly as high as it can be. No, L is 0, R is 1. Well, yeah. L is less than R minus 1. Now this is 22, K is 1, you get 0. That seems right. So if L is less than R minus 1, you can at least go up or down still. If L is less than R, it could be R minus 1. If you increased it, it would be a nonsense value. Shit. Damn, is this not optimal? No, that shouldn't show up here. How many options are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it includes everything. Zero and 4, 0 and 3, 0 and 2, 0 and 1. 1 and 4, 1 and 3. Well, I don't add it to seam. That's not good. This is sloppy. Zero and 4, 0 and 3, 0 and 2, 0 and 1. 1 and 4, 1 and 3, 1 and 2. 2 and 4, 2 and 3, 3 and 4. And that should be it. Guess I'll just submit again, I don't know. Okay, that's pretty speedy. This wasn't the hardest contest though. Oh shit. I'll take it. Okay. I don't know what was the lesson to be learned with this one. I forgot the scene set. That was obvious. And I had an off by 1. This should have been L is less than R minus 1. Because you're incrementing to the next thing. So L is less than R, and this is a valid subarray, but L is less than R minus 1. That means the next thing will be a valid subarray. I think the thing that saved me here was I immediately recognized, I think when I compared both of them, I was like, you can just obviously do this. And I recognized that by being like, what are the differences and why would this be way easier? I think that little bit of metagaming helped a lot. And then from that, I was like, okay, well, if the whole subarray is the best, then there's monotonicity. Whenever you decrease the size of the subarray, it will always be equal to or worse. So therefore, it's just kind of a simple heap greedy approach. I think that was like not obvious, and that was quite lucky of me to land on that quickly. Forgetting the scene set was just really sloppy. I haven't done Leetcode in like months. Not months, but weeks. So that's probably why. So I'll take it. Coming back after weeks, getting 59. Looks like that's not including cheaters. Damn, I was on pace. If I didn't get these errors, I'd be like top 30. Okay. Div 1, div 2. Do this, I guess. Oops. The numbers of occurrences of any of its elements are the same. 1, 1, 3, 3, 6, 6. Go to non-decreasing array A, find the length of its longest balanced subsequence. Okay, well, I guess you take a counter. Dang, that's like not super. It seems a little complicated for an A. So you take a counter, and then you kind of like decrease through the descending values and you add them up. Right? Because you could have like 1, 2, 3, 3. The answer here should be 3, because you can say just take the 1, the 2, and the 3. N and then all A. Is that how I set that up? Yeah, but I never use that. I don't want to use this. C at X goes up. So now I have the counter, and then I can say int pop equals 0, int cur equals c dot r begin dot second. This is the current population you're looking at. Like that. Yeah. Int. Well, how big can it be? Not that big. For auto X equals C dot R begin. No, I'm not even gonna do that. I'm just gonna say for auto X in, is it that? Oh, it's a minus minus. Oh no, it's not that. Okay, it's plus plus. X is less than C dot R end. X plus plus. So it should say it's got a 4 and a 1, 5, 4, 3, 2, 1, and a 3. Four and 1 and 0. 2, 1, 0. 5, 4, 3, 2, 1, 0. 3 and 0. Oh, I didn't see the 1 and 2. So I guess I just ignore the 0. Why is that there? 140, 120, 123453030. What's the logic there? I don't think C at 0 is ever called. Whatever. Shouldn't really matter anyway. So the counter, and then I think I just want a counter of that counter. So I just care about the fact that there's 3 of a thing. And then I'm like, how many things are there 3 of? How many things are there 2 of? Oh, it's just MSF is there. I'm an idiot. Okay. So C at F plus plus. Cur is that, MSF is that. For X and C, not relevant. X is C dot begin. So I think I'll just call this V. Auto accent F equals V. So I should see for the first one 3 and 2. 3 and 1, 2 and 1. 1 and 2, 5, 4, 3, 2, 1. Okay, looks good. No, this doesn't look right. No, that is right. That is right. I think I don't need cur anymore. I say pop plus equals F, MSF equals max, MSF pop times X. $4295. N sets, where each element in the sets is an integer between 1 and m. Three and 2, so 3 sets going up to 2. Choose some sets such that every integer between 1 and m is included, whether there exists at least 3 ways to choose the sets. Well, couldn't you say, look at every number, how many sets is that in? If there's ever a number that's in less than 3 sets, it doesn't work. If it's in at least 3 sets for every number, you should be good. If a number's only in 2 sets, you have like that, I don't know. So you're saying these numbers are only in 2 sets. Then you know that every single collection of sets is going to need one of these two. So there's only 2 ways. And you know if for everything there's 3 or more, then you'll always be able to. So if there's less than 3, you can't. If there's more than 3, you can. Therefore, this is the necessary and sufficient. Is that right? So this proves necessity. And I'm certain of that. If there's any number where there's less than 3, then you need one of these 2 or 1 set to work. Okay, all that's left is proving sufficiency. So is there any world where there's at least 3 sets that have every number? Where it's not possible? That would mean that even though there's 3, you can't choose one of these. Which I think is not true. So I'm going to go with that. One and n. Okay. The number of sets in the upper bound, the ith line containing an integer, the size of the set, follow. Okay, so 2, 1, and 2, 2, 1, and 1, 1, blah, 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 blah. Yeah, that looks good. Is less than or equal to m. Get x, see it x plus plus. Okay. For I from 1 to n plus 1, valid or equals c at, I'm calling this x, is greater than or equal to 3. And equals. No, 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 yes, no, no. Yes, no, no, yes, yes, no. So for this first one, 2, 1, 2, 1, 1, 1, 2. So I should say Oh, in at least one of the chosen sets. No, that doesn't mean anything. So how are there 3 ways to choose the sets here? Seems like there's 0 ways. You have a 1 and a 2, a 1 and a 2. No, that's not true. I guess it's really just 2, huh? If you have 3, you can choose any one of the 3. If you have 2, you can choose this one or both. Okay, maybe that makes it work. Yes, no, no, yes, no, no. Yes, no, no, yes, yes, no. 1, 2, 3, 4. So single 1, a single 2, a single 3, a single 4, and 2 5s. I see. So I guess it's really for every subarray. Is there any subarray that's not necessary? The moment there's a subarray that's not necessary? No, that's not quite enough too. You need 2 subarrays that aren't necessary. If you have 1 subarray that's not, or 1 set that's not necessary, you're saying include it and don't include it. Those are both valid, but that might be it. You need another one that you can not include. Okay. C at x plus plus. For every element. X and A at I. If C at X is less than 2, needed equals 1, break. So res is the amount that aren't needed. So then this could just be res is greater than 1. Yes, no, yes, 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 no. 1, 2, 3, 4, 1, 2, 3, 4. So you could have only this one, only this one, or both, except that m is 5. So I want another check that's just c at x is less than 2. Guess there's no reason to have that. Yes, no, no, yes, yes, no. Okay. Given an integer n and a binary string s of length n, for permutation p of length n and an integer x, we define find as the following pseudocode. Okay. Some sort of binary search. We call an integer x for permutation p. Okay, m is a random number. If it's x, then we found the index. P at m is greater than x, r is m minus 1. Okay. Looks pretty good, I guess. Call an integer stable if and only if find at x is always not undefined. So you never skipped it. So there's no world where m was wrong. So L and R are the inclusive bounds. You have to construct a permutation p of length n such that for each thing, integer I is stable if and only if s at I is equal to 1. Ah, okay, okay. So what's a world where one number is stable and another one is not? 1, 2, 3, yes. 1, 2, 4, okay, that's fine. No, that's not possible. Yes, this is possible. So specifically 3, oh, I see, every number below it. You can have every number below it be the number below it, and every number above it be the number above it. So how do you... So here you'd have like 4, 3, 2, 1, 5, 7, 6, 8, 9, 11, 10. 2 and 4, 3, 5, 7, 6, 8, 9, 11, 10. So what's a world where it doesn't work? Here it doesn't work. Because you need to have if you ever have a single 0, it's not possible. Because this needs to be not a 1, and then these needed it to be a 1. So that's not possible. If you have 1, 0, 1, I think this is not possible. No, not necessarily. Because if you had like 0, 0, 1, 0, 1, you could say 2, 1, 3, 4, 5. No, that's not possible. Yeah. because the 4 needs to be not where it is, but if it's before the 3, it's not valid, and if it's after the 5, it's not valid. So all the groups of zeros have to be multiple zeros. I think that's really the only consideration. You just need to have multiple zeros, and then you can just rotate them. If you ever don't have multiple zeros, it doesn't work. Yeah. Okay. N and then S. What is this, C? Yeah. One. Perfect. Int L equals -1. And no, I don't need a pop. If, or maybe I'll just call this J. If X is 0, continue. Yeah, J will be the location of the last one. If J is equal to I minus 2, then you're fucked. J is I. Okay, and then there's one more thing that needs to happen. Let's see, you're going from something down to I. I guess you just go backwards. Resid I minus k is equal to I plus k plus 1. So it should say, make this my own thing, be that plus 1, be that plus 2. No, that's not what I want. Yes, 1, 2, 3. Okay, yes, yes, no, yes, yes, no. That looks good. So here it should say I is 2, J is -1, oh, well, I say J equals I. Three, 2, 3. That should be 2, 1, 3. Perfect. 4, 3, 2, 1, 5, 7, 6, 8, 9. Two, 1, 3, 7, 6, 5, 4. 2, 1, 3. 2, 1, 3, 7, 6, 5, 4. That seems right. 5, 4, 3, 2, 1. That works. That doesn't work. It correctly identifies that. Yeah, okay. Fuck. I think at the end, you could have it fuck up. You could say, if the final thing is a 0. If you had like 1, 1, 1, 0, you need to say 1, 2, 3, and then this is 4 question mark, and mine would say, yeah, 1, 2, 3, 4 works, but it doesn't. There we go. Two integers L and R. Let n equal r minus L plus 1 will create two arrays A and B, both consisting of n integers. Essentially, both A and B are equal to L through R. You have to reorder the array A arbitrarily to maximize the following value. The sum from 1 to n of A at I or B at I. Interesting. In this version, L is 0, R is 2 times 10 to the 5th. This feels like an Eulerian path problem. A. Oh, no. A at I or B at I. Yeah, still though. I don't know. If you can maximize, If A at I is some number and B at I is some other number, why would you not pair the same B at I with the corresponding A at I if that's the maximized number? I feel like you would always do that. Like if you have 1, 2, 3, and 4, you'd say, well, I might as well pair 2 with 1. This maximizes that. In which case, I for sure want to maximize, I want to pair 1 with 2, because this is optimal, or else I wouldn't have chosen it here. And also, when I chose this, it's both the optimal choice for 1 and the best choice I can form for 2. So I think you would just say 2 and 1 go together. And then you'd say 4 and 3. Or alternatively, you could have said 4 and 1 is optimal. Well, could you? No. Because then you could say 1 and 2. And then you're fucked for 2 and 3. So you need to pair 4 and 3. What is the sum from 1 to n? You want to pair everything that you can with something with a differing highest bit. So that you're not wasting this highest bit. So you'd say, draw a partition here. Everything on that side has to be paired with everything on this side. Why would it matter? Why would the size of L and R matter? So you could partition that. Okay. You'd move down to the 2's place. You'd say these share a 2-bit, therefore there needs to be a partition there. But how would you know that? Because you'd have to say one of these goes to this. And the other one goes to this, and there's no way to know. So you would either right here need to do something greedy, or have some sort of divide and conquer approach. there any world where you don't just take the largest number? I don't think so. No, there could be. But what if you did? You'd say take the largest number complementary to 4, that's 3, pair that. Then this is all you're looking at. You'd say take the largest number complementary to 2 that's left, that's the 1. So you're good. Okay. What about a bigger example? So here you'd say draw the partition there. Look at 11. What's the largest number that's completely complementary to it? None. So then I guess you're fucked. No, you're not, because you'd say you would never ever pair it with any of these. That's off limits, so it has to be paired with one of these. If it has to be paired with one of these, you take the number with the least conflicts. Right? Which would be 5. So you'd say 11 and 5, that gets you 15. Plus 10, the number with the least conflicts is 6. So that gets you 12. Plus 9 and 7, but that's not right because you could have done 8 and 7 and that would have been better. So this is out the window. Six and 9, so 15 plus 5 and 10 gets you 15 plus 11. goes with, I guess, 17. For virtual, I'm doing 1052. I feel like I'm kind of just skipping to the hard version, which is not super advised because I'm just not really seeing how you can utilize the fact that this is bounded. I feel like you must be able to do some sort of like sieve-esque thing, but I'm kind of just like, I feel like I can almost just skip to the hard, which might not be a very good idea, but whatever. So my idea is you always want to pair it with the most complementary thing. I mean, well, not really, but you want to pair it overall so that it's the most complementary. I'm kind of looking at this and I'm like, almost definitionally, there's a greedy aspect here. Like you're looking to optimize this. I can't imagine that's going to be DP because there's not really any aggregate that's usable. So what I'm noticing is across powers of 2, like you have an exact hierarchy you always want to use to optimize it. And then I'm kind of like, if you're not across powers of 2, for example, 10, 11, 12, 13, then they all have 8s already. You have to pair the 8s. Like if they all have the same set bit, highest set bit, then you didn't cross a power of 2. Like it wasn't like 15, 16, 17 or anything. And in this case, you have to bite the bullet. Everything is going to have an 8. So you just say, okay, like 8 times n. Or in this example, 12, 13, 14, you say, okay, I have 3 8s. That's just going to happen. And then you'd say, okay, like just get rid of the 8s, ignore those because that's a non-factor. So now you're at 4, 5, 6. You still have 3 4s, so you do the same thing, and now you're to 0, 1, 2. If you ignore the 8 set bit and the 4 set bit, and now you can say, I have this dividing line. If I didn't have this dividing line, yeah, then they would all have the same set bit. So then I can say, okay, cross this dividing line, pair 1 with 2, pair 0 with 3, and so on, until either here you would have just the 0, or in a situation where you have like, if you came down from some other state to this state, you would say, okay, well then pair the 3 with the 4, that's out of the picture. Now I just have 5, 6, 7, and then that continues down to 1, 2, 3. And then you have this, you pair the 1 with the 2, you have just the 3, so that goes down to 1. All right, well, you have a single number then, so then you just take that with itself. I think this is going off of an assumption that what you're essentially doing is pairing numbers, and my thought process is like, if you have x sub I and y sub j, or a sub I and b sub j, that you're pairing with each other, there's no reason why you wouldn't also have a sub j and b sub I. Like, I don't see why you would ever not have this. Because if you chose to pair them initially, let's say this is optimal. If this is the optimal choice given all the other options, then that means that also conversely, even when you take this out, when you take out b sub j and a sub I, which would just make this, that's the least optimal choice, then this is both the optimal choice for b sub I and the optimal choice for a sub j. Now it comes down to the specific math. So if you had like 11, 12, 13, 14, you'd say, okay, these go down. You're immediately garnering 4 times 8. Everything has this power of 2. So then you're at 3, 4, 5, 6. You say pair the 3 with the 4. So then you get 3 or 4 plus 4 or 3. Yeah. Now you're to 5 and 6. Now no matter what you do, you're going to get 4 times 2. So then this goes to 1 and 2. And then you get 1 or 2 plus 2 or 1. That seems pretty good. I don't know. Is this 4? I don't think this is 4 times. No, this is 4 times 8. It's kind of like you're choosing to double. You get 14 here from pairing the 4 and the 3. As opposed to if you paired like the 3 and another 3, you would have gotten 0 or something. Or no, you would have gotten just 3. No, is that right? No, you would have gotten 6. 3 or 3 plus 3 or 3. There's 2 of them. Okay. Yeah. R plus 1 minus L. I think I almost want to just use a DFS. I think that's easier. Res is N. $240. I don't think I even need to like figure out what the answer is until the end. Yeah, I think you just kind of like go down by that amount. CLZ built-in CLZ. Built-in CLZ of 1 is 31. Therefore, you'd say the highest set bit is the 31 minus that set bit. $33, $35, $35. Shit. Whatever. It is 0. I gotta pee. Okay. I think I need more info than this because I can't just use LNR. I need to also. Hey. The left and right indices. I could also just have the bit. Doesn't really matter. the highest set bit. So while 1 to the bit is less than or equal to, and then you subtract 1. Okay, so you're in 3, it says the highest set bit is 1, that's wrong. 9 is 3, 15 is 3, so why would it say 1? It'd say 1 to the bit, 1 to the 0 is 1, 1 to the 2 is, or 1 to the 1 is 2. One of the 2 is 4. Maybe it's just this. 2, 4, 4. That seems more right. What happens if like r equals 4? 2, 2, 2. No, that's still right. No, that's not right. I think this might have been right. Less than or equal to r. So it should say 0, you're good. 1, you're good. No, what am I talking about? This is right. 1 is right. This should be 2. Okay. If r and x doesn't equal l and x, then just do this. DFS L, no, if it equals L and X. Bit minus 1. You're looking at the next lower bit. Yeah, I think that's okay. Bit minus 1. I and j I actually think are not necessary. No, they are. Yeah, I think they are. Then it doesn't change. L x or x, r x or x, bit minus 1, res. No, you could just offset though. could say, what's the offset? Yeah. Offset XOR X. Hey, if you pass the Leetcode, are you guaranteed the job? No. I don't think so these days. From what I've seen, it seems like many candidates do not pass the Leetcode, so it's probably still like worthwhile to do. I think there's a world where it's just like everybody passes it all the time and it doesn't matter, and then it's just like another hoop you have to jump through. In that world, it's like probably it doesn't really pay off to study Leetcode. But in a world where like half of candidates don't pass that round and half do, like then that's pretty worth it. Or especially like at least the way it used to be a few years ago, like felt like that was the make or break. Like it was quite easy to get an interview at Google, but it was really hard to like pass the round where they like make sure you're a genius or whatever. That's where it's like super worth it, and I felt like everybody was grinding Leetcode. But these days, I don't. I think cheating has like complicated it, like LLMs and stuff. But um, I've also noticed a little. I don't know if it's as important these days as other things. Self, do that, and self. So I'm saying decrease L by X, decrease R by X. Look at the next bit over. Add X into the offset. Okay. Or else you know for a fact that there's something on either side of X. If you know there's something on either side of X, you can say LLI equals X while I is greater than or equal to L and I is less than or equal to R. No, not that. X minus I is greater than or equal to L and X plus 1 plus I is greater than or equal to R. So you're going to pair like 4 with 3, 5 with 2, 6 with 1, and so on. Something something I plus plus. And then if I equals L, then something else something. And this is going to be DFS. Okay, if I is L, then it's going to be X plus. If you had 3, 4, 5, you'd say I is 0. Say I is 0 and then I went up to 1. This is backwards. X minus 1 minus I, X plus I. So if I minus 1 minus I is equal to L, that means you paired 4 with 3 and now you want to just have the 5 and on. So you'd say X plus 1 plus I is the new left bound. The right bound stays the same. The bit stays the same. The offset stays the same. Res and self are always the same. Cannot be referenced in a lambda body unless it's in a capture list. Fuck. Oh, because this is self. Like in Wall Street, 10% of tier 1 firms won't hire you if you pass the technical interview because the top names get people with crazy backgrounds, but the majority tier 1 firms will give you a shot if you can pass the technical interview because that's how few people pass the interviews. I think like, I mean, it depends. I think if you're like a regular programmer and you have like 5 years experience or something, and then also you're like a whiz and you ace the interview, like, yeah, they'll probably like give you a chance, maybe. Um, but I mean, like, there's a limit, you know. Like, if you're like a junior developer and you have like 1 year experience, and you went to like kind of a no-name college, then I think they won't care. Like, it doesn't matter how well you do. It's like it doesn't matter. I guess it's not like this for big tech. OS rated 2600. Oh, is rated 2600 top tier. I think rated 2600 is pretty good. I think that I know people that work in quant that are about this level. I know people that are well above this level. I haven't done a contest in a really long time, but I did a virtual today and I got 59th. That felt pretty good. Like for quant trading, if you come from a non-target university background and you can pass the technical interview, they will give you a shot. Will they give you a shot? They will give you a shot. Heck, I don't even have a degree and I was told they would give me a shot. Fresh grad. If you're a fresh grad, I think it's different because they have roles that are like specifically for that. Yeah, I think as far as that goes, there's like a whole like YouTube ecosystem that like fetishizes the new grad to quant pipeline and like how to get into Citadel and answer all these questions. There's probably something to it. I think going to a really prestigious school helps. Um, and from what I've heard too, like having a really wide breadth of knowledge helps too. Like if you know C++ really well and you know machine learning pretty well and you know your DSA pretty well, like and you know your math well, like if you have all those things, I think it's less a matter of standing out and like being so amazing that they're like, oh, okay, well, there's this like, you have these weird red flags, um, but like you're such a genius that it's fine. Like I think people like to think that it works that way, but it doesn't. I think the way it works more is like, is there anything where you're noticeably not great? If so, they're not going to hire you because it's not a game of like taking a risk. Like even if they are like, yeah, you're probably amazing and you're going to do great things, like it's not worth their time. Self from L to x plus 1 plus I, x plus I. So if you had 2, 3, 4, you would want to just have the 2. No, so it'd be x minus 1 minus I. So you'd say pair the 3 and the 4, I goes up. I is now equal to x minus 1 minus I would be 2. If it's less than L, if it's equal to L, you still have that. If it's less than L, you did everything. This would be have the 2, x minus 1 minus I. No, I think it'd just be x minus I. Oops. Because you'd say pair 4 and 3, I goes up, I is now 1. That would be x minus 1 minus I. I is 1. X minus 1 minus 1 is 2. You'd say go from 2 to 2. That's right. That's the right bound. The bit is the same. The offset's the same. Res and self are the same. Okay, there's one more thing, which is if, well, let's see. If bit equals 0, return, then you're done. Okay. Their interviews are OA. I heard some people are switching back because LLM cheating's so bad. Well, this loop's not supposed to happen. There's clearly supposed to be something here. This is where I'm actually assigning the res values. No, this loop won't go infinitely. It just doesn't do anything. Yeah, okay. So as far as I'm concerned, this is working as intended. X minus 1 minus I is greater than or equal to L. So I'm saying pair the 4 with 3. I'm going to add the offset in. I'm going to subtract L. That's the index. Okay. So I could say LL Y, or I'll say Rx is equal to X minus 1 minus I. No, that's LX. Rx is equal to X plus I. But plus offset. Okay, and then I assign them to each other. So res at Lx minus, damn, I need the original L. Whatever. LB is equal to Rx. Res at Rx minus LB is equal to Lx. And then keep going. Okay. And then can I print res? 4. Well, there's a single while loop. So that's kind of odd. Okay, bit is just 1 forever. Like for big tech, they won't even give me an OA if I don't have a reputable college background or work experience, but in quant trading, it doesn't matter. Just copy and pasting some basic quant finance GitHub projects and being able to explain it as your own is enough to get you the interview at most top tier firms. I didn't know that. It's interesting. That makes sense with big tech. Yeah. I think you also I think this is not true with quant, but it is, from what I've seen, somewhat true with big tech, that it really, really helps to know people because there's just such a flood of applications. Or do you know if I can use some kind of keywords to get interviews? I don't know about that. I don't know about that, but I know that like knowing people helps. And there's a whole world to like messaging recruiters and like asking how their day is and stuff like that. I wouldn't do that, but okay, it's always 1. So what's happening here? It's always 5 and 3, which is not right. So somewhere along the way, x plus 1 plus I and r, or L and x minus 1 minus I. So if x minus 1 minus I is less than L, that means you went out of bounds. So x plus 1 plus I is, well, let's just go back. Let's just have one test case. That's the one that matters. So from 0 to 3, it fucks up, which is really weird. Okay. Let's try it again. So it says you have 0, you have 3, you're looking at the first bit. Okay. If L and 2 is equal to x and 2, that should not happen. Okay, good. So then this happens. should say pair the 1 with the 2 and the 0 with the 3. And then it should just be done. So why did that not happen here? It should say 1 and then 2. No. Oh, because I say I is equal to x. That doesn't mean anything. One and then 2. So it says 3, 2, 1, 0. That seems much more right. No, still getting in an infinite loop. If L is exactly equal to R, so bit is 0, do that. If L equals R, well, how did that happen? How did L become equal to R in this case? So 3 and 2, so then it said 3, 2, 1, 0. X minus 1 minus I is 2. X is 2, so this should say negative 1. Okay. So then it says this happens, so now you go up. X plus 1 plus I will go to 2 plus 1 plus 2 is 5. Which seems way too high, so it's probably x minus 1 plus I. That would make it go up to 3, or it's just x plus I. Because you'd say now if there's a 4 and on, which seems right. Shit. X plus 1 plus I. No, just x plus I and R. 4 and 3. And then I think it's nonsense from there. So I can probably just say if bit is equal to 0 or, well, if bit is equal to 0, does that mean anything? I don't know. What would be a world where bit is equal to 0? It's saying I don't think that means anything. L is greater than R, return. Else if L equals R, then something in return. And this would be X is X minus 1 plus offset minus LB. Res at LX can be equal to Lx. You're saying get the actual value that L corresponds to and R, and say this pairs with itself. Okay, there we go. So it said, you have from 0 to 3, the bit you're looking at is 1. Immediately from this, you center on 2 to the 1, which is 2. You say pair 1 with 2 and 0 with 3. And then you'd say, okay, you're looking at your new bounds are -1 and 4. So go here. Now you're looking at from 4 to 3, which doesn't mean anything. So continue or return. 0, 7, 3. Shit. 0 and 7. So it clearly said pair 8 with 9. And then now you're at 0 and 7. But 3 is not the right bit. But it should say correctly R and X is equal to L and X, because (0 and 8 is equal to 7 and 8. So 0 and 7, it's saying you're looking at the 2, but in this world we were looking at 3. So you're looking from 0 to 9. 0 and 8, those are not equal. Okay, now you're looking from 0 to 5, which seems not right. Okay, and then 0 to 7. So right here I need to say, well, what the hell does this mean, 0 to 5? How did it get there? Zero and 9. I is 2. So you're going from 0 to 8 minus 1 minus 2 is 5. But I don't think that's right. I think this maybe is plus 1. Okay, and then you're going 0 to 7. And then I need one additional corner case, which is if something, do this, if L and X equals 1, or if it's not 0, do that. Else, it's going to be really similar, self L R bit minus 1, offset res self. So the idea is if you're entirely under a power of 2, just keep going. Hmm, 0 and 7, 0 and 9. So if it's 0 and 7, it should say bit goes down. Today's div 2? I don't know if this was today. I think this was a while ago. No, that's something else. I don't know. It was 10:52. I'm getting really caught up just skipping to the hard version, but I feel I'm like so close. So you're saying, okay, if L and X is 0, you're saying this power of 2 doesn't matter. So just go down. This really should print this test, but it doesn't. 0, 2, 0, 2, 0, 2. Okay, it's printing that for I. It's not printing this though. So let's walk through. So if it's 0 and 9, if L is greater than R, no, no. If L and X is R and X, no, because R and X is 8, L and X is 0. I is 0, so do this. This is gonna assign, it's gonna pair 8 with 9. But it doesn't, it pairs 7. It says pair, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, yeah, it says pair 7 with 8, 6 with 9. That's correct. Yeah, and then it goes down to 5. Okay, so the 5 was correct. I'm just bugging out. Man, but it goes back to that. L X minus 1 minus I. So it should say 0 and 5. Okay. And then the bit. So then it's, this is then 0 and 5 and 3. It should say that doesn't matter, that doesn't matter. This, though, is true. So this should happen. If okay. 0, 9, and 3, 0, and 5, and 3. But this should absolutely happen. X is 8. So 0 and X is equal to R and X. one of these terms is not, I like reused it somewhere on accident or something. No, I think it's just L and R are longs. No, that's not right. Okay. So here ln x is 0, rn x is 8. Here ln x is 0, rn x is 0. Okay. They are equal. So directly, this is exactly equal, but this test doesn't go through. If I just said if z equals z1, does that work? Okay. Hmm. Zero, 9, and 3, 0, 5, and 3, and then this goes through. It says 8, 13, and 3. So I think it's the same thing here. Where it's confused. Okay, and then it goes to 0, 5, and 2. That was unbelievably confusing. It must have to do with like bitwise operations with LLs and ints. Oh wait, was that it? Yeah. 1, 0, 5, 4, 3, 2, 9, 8, 7, 6. So it said 9 and 8 pairs with 7 and 6. And then 5, 4, 3, and 2 pair together, and then 1 and 0. Yeah, that seems right. I don't know. This might just not be, there might not be the proof of correctness here, but I thought it was pretty good. Print, print, print. I think I got rid of all of them. Three, two, 1, 0. 7, 8, 5, 4. There. How do I want to do that? One and iota test1 dot begin, test1 dot end, and then it's going to go from L. Oh my god, that's sloppy. equals 0 to n. X is equal to, what am I doing? It's the sum of all these? Yeah. L plus I or A at I plus A at I. $12.92.40. Looks pretty good, I guess. I don't know. Maybe I'll check it with the other one. $12.92.40, 70, 20, 62, 20, 28, 3 something 39. So that said 879. Mine said 770. Shit. 4365 2143 202143. No, that's right. 62. I said 97760, which is not right. Blah 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 blah. Okay, it said, looking at every number from 6 to 10, so 6, 7, 8, 9, 10, it should say 7 and 8, 6 and 9, 10 and 10, but it doesn't do that. It does correctly identify 10 and 10. It doesn't really get that right, though. No, fuck that. Says this goes in the 7th spot. Lx is x plus 1 minus offset. I don't think x is right. I think it's L plus 1 minus offset. Or L minus 1 plus offset. L equals R. This should say 10. So these might be a little too confusing. I think the minus 1 is like not necessary. No. Oh, well, that I think that did fix it. 9, 8, 7, 6, 10. Three, 39, 28, 20, 70, 2, 40, 90, 12. Okay. Looks good. Okay, that's a very good sign. Now I just need to make sure it works with LLs. It doesn't like freak out and give something negative. Never seen that before. Well, that's probably way too big. Looks pretty good. Yeah. Copy, paste, and then this one will be hard version. I'll take it. That's pretty good. I didn't understand that at all, but. Find a weight of an array B consisting of m non-negative integers and the number of indices satisfying B at I is greater than max of B. Here max of B denotes the minimum excluded of the integers in B. Read that. So from the maximum weight over all subarrays of A ending in index I. In other words, you have to find the max of weight of L to I for every L below I. For every I. The maximum weight. The weight of an array is the number of indices satisfying it's greater than the max. Why would it ever not just be 0 to I? Because you could introduce a number that if you had like 3, 4, 5 and then you introduced a 0, or like 3, 4, 5, 5 and you introduced a 0, you'd go from 4 is the score to 3 is the score. No, that's not true. You go from 4 to 5. No, you go from 4 to 0 because it's B at I is greater than max of B. So you would need to keep track of where a 1 is and a 0 and a 2. You'd keep going back. You'd say, where's the furthest back I go. And then you would need to have probably a segment tree that says the number of elements where b at I is greater than max of b for a given max value. So yeah, I guess you just have a count. You'd say, I don't even know if you need a segment tree. What's the count of values up to index I? No, you would. And then I guess you could have a monotonic stack that's like how far back until MX appears. No. So if you had this, and you're currently here, and you're looking backwards, you'd say, I don't care, I don't care, I don't care about anything right up until the 0, where then this jumps up to the max is 4. So optimally, you would go to this 3. Here you'd say, don't care, right up until the 0. Then the max is 0, or is 1. Right up to the 1, now the max is 6. No, the max would be 3. And then the 3. So you're going to get this decreasing subsequence. I think you know for a fact that all these numbers are greater than these. So when you go to this 0, when you go to this 1, you need a way to say, and the partition is now here. Or this is the number of elements above 1. Probably not a permutation either. No. So the weight of this is 4. You immediately know that, because you have all these. Here, the weight is also 4, because you have all these. Here, the weight is 1, because you have just this. So you could say, this is the next decreasing thing. You could keep a prefix minimum on the stack. Keep a prefix minimum on the stack. You say, okay, when I see a 0, I point to the 4. When I see the 4, I point to the 1. When I see the 3, this points to like negative infinity. This is, you don't have anything. You have every single number. But this is only if it's a permutation. This makes any sense? Yeah, I think this wouldn't work. Because if you had a 1 here and a 2 here, the whole thing's shot. Because here you're like, the max is 1. That's all I really care about. So just go all the way back or whatever. Here though, you'd say, oh, now the max is 5. Three times 10 to the 5th. Well, no, actually, the max would be here. The max is 0. Here, the max is 3. And then here, the max is 5. Oh, good boy. Yeah. Oh boy. I gotta get going. 10 more minutes. I think I really shouldn't. I think I need to just go. Yeah. That's pretty good performance though. I think, I don't know. I actually oftentimes can do div 2e, so I think I probably actually did spend too much time on d2. But that's okay. You get a monotonically increasing max. And it can jump wildly. And you get a monotonically increasing number of elements going backwards. And that goes up by exactly 1 every time. So I guess you could just record this as the max minus the index or something. And then that gets you a pretty, and then you keep a prefix minimum of that. Or like the max plus I or something. You want the minimum max, the minimum score that doesn't really tell you how many elements are above or below the max though. Because it's number of elements, not A only goes up to n. think you could have a segment tree of your stack. Or not even that. I think you could just have a segment tree on the previous elements in the array. And say, okay, you introduced a 1. Does that change the mex of anything? That's sloppy. No, I don't know. You introduce a 1, that changes this mex to a 3. No. Oh well, I'll think on this one. Alright, I'm out. Thanks for watching.